Good day. Today's lecture topic is Security and Application Integration. We will examine how to ensure information protection at the database architecture level, configure access rights, and organize secure and effective interaction with software. We will structure today's session as follows. First, we will break down the fundamental security model in relational databases. It's important to understand the difference between authentication and authorization, as this is the foundation of any system's protection. Second, we will move on to practice and look at DCL, Data Control Language, a special group of SQL commands that allow administrators to create users and flexibly configure their permissions. Third, we will discuss a critically important topic for web application security, SQL injections. We will see how they work and, more importantly, how to protect against them using parameterized queries. And finally, we will consider modern SQL capabilities for working with JSON. This allows for effective integration of the database with web services and APIs, reducing the load on the backend. The foundation of any database's protection is the two-tier security model. It is based on the distinction between two key concepts: authentication and authorization. The first stage is authentication. This is the answer to the question, who are you? When a user or application tries to connect to the server, the DBMS must check if such an account exists and if the provided credentials, password, certificate, etc., are valid. Technically, this can be as simple as checking a login password pair or a complex integration with corporate directories like Active Directory. The second stage only occurs after successfully passing the first. This is authorization. Here, the system answers the question, what are you allowed to do? Even if we have identified the user, it doesn't mean they have access to all data. Authorization defines specific rights. Can this user read this table? Can they execute this procedure? This mechanism is implemented through a system of privileges and roles. Let's move on to the technical implementation of access policies. For this, the SQL standard provides a separate group of commands, DCL, or Data Control Language. Administration begins with the Create User command. At this stage, we create a new account and specify how the user will confirm their identity, for example, by setting a password. Next, we use the Grant command to assign rights. It allows us to clearly specify who, what, and where they can do something. For example, allowing a user only to read data from a specific table. If rights need to be taken away or restricted, the REVOKE command is used. I want to draw special attention to the principle of least privilege. This is the golden rule of security. A user or application should only be granted the rights that are critically necessary for their functions. This significantly reduces the damage in case the account is compromised. This slide shows a typical life cycle of configuring access for a web application. First, we create a new user, student app. Note the @localhost part. This restricts connection possibilities to only the local machine, which is an additional security measure. Second, using the Grant command, we implement the principle of least privilege. The application is only allowed to view, select, and create new orders, insert, in the shopdb.orders table. It is not granted any rights to change the table structure or perform administrative tasks. Third, the REVOKE command demonstrates how to take away rights. For example, if we accidentally granted the right to delete, or the security policy has changed, we can specifically revoke this permission without deleting the user itself. Let's move on to discussing SQL injection. This is one of the most common and dangerous vulnerabilities in web applications. The essence of the attack is that an attacker, through ordinary input data, like a login field on a website, passes a fragment of SQL code that the server perceives as part of the command. The root of the problem lies in improper query formation, when a programmer simply glues, concatenates, the query string with a variable's value. Look at the code example on the slide. If you enter the string or1 = 1 instead of a username, the query structure changes radically. The where clause becomes always true because 1 always equals 1. As a result, the DBMS, instead of searching for a specific user, returns the content of the entire table or allows logging in without a password. The primary and most reliable method of protection against SQL injections is the use of parameterized queries, also known as prepared statements. What is the essence of this method? With this approach, we do not concatenate the query string ourselves. Instead, we send a query template with special markers, placeholders, often a question mark, to the database. The data itself is sent separately. The DBMS works as follows. First, it receives the template, checks its syntax, and builds an execution plan, compiles the query. Only then are the variable values substituted into the already compiled query. Because of this, even if an attacker sends malicious code, like or 1 equals 1, the database will perceive it simply as a strange set of characters to be found in the name field, not as a logical OR instruction. Furthermore, don't forget about layered defense. Always validate data on input and use modern ORM libraries, which usually implement parameterization out of the box. Modern relational databases, such as MySQL and PostgreSQL, have adapted to the demands of web development and integrated support for the JSON format. This effectively gives us NoSQL capabilities within a classic SQL environment. We can now store data with a flexible structure without having to change the table schema with the alter table command every time. This is particularly valuable in API development. Previously, we would select raw rows from the database, pass them to the server, e.g. Python or Java, and then form the JSON for the front end in loops. This created an unnecessary load. Using built-in JSON functions allows us to delegate this task to the DBMS and receive a ready-made object immediately. This not only simplifies the backend code, but also reduces the amount of data transmitted over the network. This slide demonstrates two key functions for generating JSON. The first function is JSON object. It allows you to construct a JSON object by simply listing pairs of arguments, a key, then a value. This is convenient for forming simple API responses. The second function, JSON array aggregate, is much more powerful. Imagine a situation. You need to get a list of product categories, and for each category, a list of the products themselves. In traditional SQL, this would require either multiple queries or additional data processing on the backend side. With JSON array aggregate combined with grouping, group by, we can collapse all related product rows into a single JSON array right inside the query. As a result, the application receives perfectly structured data, ready to be sent to the front end. This concludes our lecture. We have covered critically important aspects of security, from the basic authentication model to protection against SQL injections, and also learned how to effectively integrate a database with web applications using JSON. Remember that security is not a one-time setup, but a continuous process. Adhere to the principle of least privilege and always validate input data. Thank you for your attention.